we want to stay in that side. So I also made some modification of my talk, where I will show you how can computer influence on your concentration in listening the talk. So be prepared. So my name is Blaz Zmazek. I'm coming from Faculty of Natural Science and Mathematics, University of Maribor, Slovenia. Slovenia was invited country first time on the first BALKAN physical OLYMPIAD this year. So very thankful for invitation also to the members of the union. So just a few pictures from Slovenia that you probably know where it is, and this is on the edge of Balkan. So this is why maybe Slovenia will also join the Balkan Union. Basic information about this: Slovenia is independent from 1991. It has about 2 million inhabitants on the area of 20,000 square kilometers, with coastline about 40 kilometers. That means 2 centimeters for each inhabitant in Slovenia. So if we would like to go to the seashore, we could not swim together. So the capital of Slovenia is Ljubljana, and it has 12 statistical regions, which you probably heard for some of them. So I would like to, because I'm a professor of mathematics, they put me on the end of the day of the sections of the lectures, but I'm dealing with physical problems. So I'm teaching discrete mathematics and also differential equations, which are part of physics, which comes from physics. So I will refer to the third problem in this competition as a graph, graph of the dynamical system. The dynamical system is a system where that change over time. So when we model the system, you usually idealize the system in terms of its state variables of the system, which are quantities that represent the system itself. So, for example, moving body, which is the example from the problem 3, may be represented by the state variable of velocity and position over time. On the other hand, we have models of population dynamics. We will see later the example. The system state variable may be the number of population, or the migrate or born and death, and the existing population. To have better understanding of this dynamical system, we will contrast the dynamic system to the static system. What is dynamic, what is static? For physics, you are clear. So static system is a system where does not change over time. So it's constant. The value of variable is static over the time. And we assume that time always start with at zero, Big Bang, or how you say. So example is the function x is 5, so you have a population of 5 persons, which is constant over time. This is one example of static system. This is static system because the value is constant over time, and we graph this system with the plot of continuous time. We can do it with continuous way, or on the bottom figure is the plot of discrete time. In contrast, we have, for example, a simple dynamic system. This is x of t is 5 point t. So the number of the value of variable x is computed as 5 times the number of the value of time. This is the graph. If you see, is linear, and we also have a comparison between the continuous and discrete. And we can combine those. So we can combine those. We can take one superposition. So we do some static system with the dynamic system, and the result will usually also depend on time. So it is again the dynamic system, and there is one example of function x is 5 times minus 2. It's superposition of examples before. So difference between discrete and continuous dynamic systems. So some systems are better represented by continuous system, while the others are best to be presented by this discrete time. In most cases, system with continuous has discrete time equivalent. So we can just cut the graph and we get a discrete graph. So what is the difference in manipulating those systems using summation? This is in a way of discrete system, and instead of integration. You are so young, so in lower grades in the high school that you probably didn't heard about integral. So this is also the reason that you can manipulate the problems which were probably in continuous system integration would need it. So in discrete system you use summation, and this is what is the main point is that also this can be compared in equations. So if we have a difference equation, it is the equality or equivalence with differential equations. We will see later what these are differentiations and difference equations are. So many students has the opinion also that discrete time system is much more easier to understand because continuous time is hardly to understand in mind. So, oops, what's happened now? What should I do? So you did it, those? I didn't. No. So did I catch your attention again? Yes. So the computer can be used to manipulate your attentions. So I have prepared my presentation using blackboard or whiteboard. Maybe because with PowerPoint it is so, it can be so boring that you have to read and to listen. And if we have such an operator which makes problems, then it's more maybe interesting. So let's go to the difference equation. What is difference equation? So the difference equation is a functional equation. So equation where function is needed result. So solution. Solution is the function which solves this equation. The differential this equation or a dynamic system, which is the same, can be seen from at least 3 points of view. First point is a sequence of numbers. This is the numbers over each time. Or discrete dynamic system, as we presented example before, or it's an iterated function. It's all the same, but we can look at it in different angles. So one very famous sequence of numbers you know the Fibonacci numbers. And you know how Fibonacci found it, you know?
Yes.
Yes.
Like there was this water problem. In the end of each month, the rabbits have like children, and he was supposed to find the number of rabbits that will exist after a certain amount of time.
Yes. So this is Fibonacci's tasks, and for the rabbits, we know that a couple of rabbits cannot have the children after 1 month, but only after 2 months. So in the first month, if you buy one couple of rabbits, and in the next month we cannot have much more. But in the third month, so I have this picture here. So in January we have one couple, in February still one couple, and in March we have 3 couples because this couple have children. So in April, only the first couple can have their children because the new couple is too young to have children. So how many couples we have in K after K months? So what depends from what the number of rabbits depends? It depends of how many rabbits we have the month before. So these rabbits will stay at the home, or yeah. And how many children will we have? As many as we have the rabbits 2 months ago, because these rabbits are now prepared to have their children. So we have to Fibonacci number. We have a recursion function. Y of k plus 2 is y of k plus 1 plus y of k. So this is one type of connection equation which defines the number of rabbits. It depends of how many rabbits we had at the beginning. So you know that this Fibonacci sequence appears in the nature every time you see in the flowers, in the plants, and also in the architecture. The other side, the other point of view is a different equation as a different discrete dynamic system, which we talked before, or as an iterated map. So if we have a map F, then we make a recursion. So we made a sequence of numbers, which are the numbers of this function, value of function at each time. So, for example, we have one recursion, one function, a square of yk. So, if we choose initial value y0 is 1, this will produce only once. So, 1 square is 1, 1 square is 1, so it's constant. On the other hand, when we choose for the initial value 2, the iterated function will generate squares of or powers of number of 2. So 2, 4, no powers, 16 to 265, and so on. And we see it's up, going up, and it's not. We cannot find the maximum number. In the other hand, the third example, if we take first initial value half, 0.5, then this sequence will go to the 0. So it will every time less. So we see that knowing the rule only is not enough to know the behavior of the sequence. That initial value is also very important. So the orbit, the sequence of the dynamic system is constant, for example, for initial value 1, for 2 is unbounded orbit, and for 0 is goes to the 0. Okay, I will skip this. So when two difference equations are equal, or dynamical system are said to be identical, if the infinity, the set of algebraic equations that they represent are identical, so they have the same orbits. They represent the same set of equations. For example, we have a system of numbers power of 3. The order of a dynamic system or differential equation is difference between the largest and the smallest arguments k appearing in it. So what is the order of the equation for Fibonacci number? It is not here, yes? How many? Yeah, 2, yes, because we have only 2 months before needed. So we have there 2 examples of order 1 and 1, 4 and 5. So just we see what is the difference between the smallest and the largest argument where k is appearing. What is the solution of difference equation? It's an expression or function or formula that makes the difference equation true for all values of the integer value k. So it has to be right value for each number k of k. So we can, the nature of the difference equation allows the solution to be calculated recursively. It is easier to see the solution of the difference equation if we have an algebraic equation. So if we have an equation which define the exact value of the function in any value of k. So this is, for example, we have different equation. It is recursively put it, and we want to find the algebraic equation how any value is calculated from n, for example. Because if we want to calculate the value of y for 2019, we should not go 2018 calculation, but we can just find the formula and compute it. So this is, for example, we can do for k is 0, we have y0 is y0. So y in 1, we use recursive formula and write y0 plus b. And this we do for example, 4 steps. And we already see what formula should be. And it is not enough that we write down the formula. We have to prove this formula. And you know the method in mathematics which is used for proving that such formulas? Yeah? Mathematical induction, yes. It's just exactly the way we can do it. And we can do it in a simple way. But in the end, we will see that we got an expression for yn in number n, and for geometric sum, we know how it is written in that way. So at the end, a and n is b times ratio of 1 minus a over n and 1 minus a. So this is for n, which is not equal to 1, because in the case n is 1, we got n times b. Yeah, it's quite easy for you. So linear. This is kind of the simplest type of linear differential equation, because linear differential equations are equations where y's are involving in this equation in linear way. So it is such as you see. And we can assume that constant coefficients are constant. So it can be shown. So in the theory, it can be shown that a general solution of such an equations, which are homogeneous, this means that gk is 0, is sum of solution of homogeneous and one particle solution. This is which we see on the example. And there are n constant which are in the solution of this equation. So to find the solution of the homogeneous linear difference equation, we assume we assume that solution is of this type. Yk is R over K. This is the method how we compute, how we find the solution of linear differential difference equation, and we quickly see how we solve the Fibonacci sequence in that way. So if we put this assumption into the equation, we get the so-called characteristic polynomial, which roots are the numbers which defines the solution. And to solve, for example, this is the example for Fibonacci sequence, where we have this sequence, this formula, this equation with initial value that at the beginning we have one pair of rabbits, and after 1 month still have one pair of rabbits. Then this formula we can transfer in the terms of left-hand side. So we put all the arguments on the left side and insert the assumption into this formula equation. So we guess that the solution is of type A times R over N, and when we put it inside, we had this characteristic polynomial, and we see R squared minus R minus 1 is characteristic polynomial for Fibonacci sequence. So this is characteristic polynomial, and because it's quadratic, it has two zeros, two roots, which are not nice, so it's ugly. They are ugly, so we have square 5. How can we then get the numbers like 1, 1, 3, 2, 3, 5, 8? So we have R1 and R2, and for any A1 and A2, these functions A1, R1 over N are the solution of this equation. So this is the solution of Fibonacci sequence. But we have to determine also the coefficient A1 and A2, and this is also checking of that this is already the solution, and we see that definitely is solution because we got a characteristic polynomial there, and we know that we choose R's as they are zeros roots of this polynomial. So the solution is of this type, and finally we have to determine A1 and A2 from the initial solution. So we put 0 into the instead of n, and 1 instead of n. We have 1. We got one equation, A1 plus A2 is 1, and the other uglier. So if we put 1, we get this is U is 1 missing. So, but by calculating this equation, we get that A1 and A2 are not, again, very nice. They're ugly, more uglier, or as the roots are. And when we put this in the formula, we get that the number of rabbits after n months is calculated by this formula. So for each number n, this is the integer. So we can observe that despite of the square roots of 5, these are the integers of okay. So this is the most famous formula for differential equations, and maybe this method is very useful for you to hear some times that you will remember. So I will not proceed with examples which I prepared also for you. Maybe it's just to show you a differential equation with the same formula. Solving differential equations where the difference between difference in differential equations are that in these differential equations in the equation differential are involving, not differentials or yeah. So, but there is the most the methods to solve the differential equations are similar to methods for difference equations. So these are the solution for differential equation. You see that it's also linear in independence function of value x. So thank you for your attention and enjoy. The most of all enjoy joining for 1 hour and 15 minutes more, which we're giving to you now. So thank you again.